You're welcome back. This is Mr. Hassan's Maths channel, and this is question number 5 from the October 2021 Statistics S1 International A-Level exam from Edexcel. This question here is about discrete random variables, and they've told us about the discrete random variable y, which has the following probability distribution. So we don't know what y is referring to, but we know that when the value of y is -9, the probability of that occurring is q, which is -5, the probability of that occurring is r, and so on with all these numbers. And they told us that q, r, u are all probabilities. And you can see here that this and this are the same, this and this are the same as well. So it's like some sort of symmetry here in the probabilities. And even the values seem to be kind of symmetrical in a way. That's -9, 9, -5, 5, 0, and so on. So it says write down the value of EY. Now, normally when you want to find EY, you have to multiply the event by the probability of it happening. So -9 times Q plus -5 times R plus 0 times U plus 5 times R plus 9 times Q. And we can see very quickly that's going to give us 0. Because if you multiply this and add the product of that, that's going to give you 0. Multiply these two and these two, and you add them, you're going to get 0, because they're the same thing but negative versions. And that times that will be 0, so it's going to give you 0 anyway. So we can quite quickly see that. But I don't think they want us to show those steps, because what you have to realize is when you have a symmetrical probability distribution like this, okay, then what happens is the item in the middle is going to be the median, or the mean in this case, right? It's going to be like the expected mean. EY means the mean or the expected mean. So it's going to be this position here. This thing here is going to be what is the mean. So we can just write down the answer without showing any steps. That shows you understand that distribution being symmetrical means the thing in the middle is the mean. Okay, so if you want to write by symmetry, you can, but you don't need to. Symmetry. I don't know if that's spelled right. Always mix up the M's and the T's. Is it double M or double T? I think that's right. But anyway, we can check it later, no problem. So you don't even have to write that down. So the answer to part A is just EY equals 0. Just by looking at the distribution, even if you don't know the values, you know the value of that and that are the same, that and that are the same, and you know it's going to be this one that is the expected mean. Okay, so that's A. Now for part B, it says the cumulative distribution function of y is fy. Given that f0 equals 19 over 30, show that the value of u is 4 over 15. So f0 refers to the sum of the probabilities up to that point. So it's a probability of -9 and -5 and 0 together. So that's what it's referring to. So it's the probability of -9 and -5 and 0, which is basically Q plus R plus U. Right, so we know that F0 equals 19 over 30, so therefore we can say Q plus R plus U is equal to 19 over 30. And what else do we know? We want to find the value of U. It's 4 over 15. We also know that the sum of the probability distributions in any probability distribution must be equal to 1. If I add up the probabilities of every item together and add them together, they must be 1. So you've got 2 Q's plus 2 R's plus U. The sum of those must all be 1. Okay, so we can say that, we can also say that 2Q plus 2R plus U must equal 1. So we have these two equations which we can try to solve simultaneously somehow to find the value of U. Now what I can spot here is some clever little substitution we can make, because this is Q plus R, this is 2Q plus 2R. Now if I take equation 1 and multiply it by 2, I'll end up with 2Q plus 2R. So let me do that. 2Q plus 2R, and then we'll have 2U equals, and 19 over 30 multiplied by 2 will give you 19 over 15. Okay, so that gives us like another equation. Now I see that I can take 2Q plus 2R, and what I can do is I can replace it with 2Q plus 2R is going to be the same as 1 minus U. if I rearrange this. So I can kind of use some sort of substitution, replace the 2q plus 2r with 1 minus u. I hope you can see that, right? That 1 minus u is equal to 2q plus 2r. So if I do that, if I replace this with 1 minus u, I'll have 1 minus u plus 2u equals 19 over 15. So I get then 1 plus u equals 19 over 15. So u is going to be 19 over 15, take away 1, which is 19 over 15, take away 15 over 15, which is 4 over 15. And I think that's what we had to show. Exactly, that's what we had to show. All right, so there we have the answer to this part of the question. We showed that u is equal to 4 over 15 with a little bit of a tricky type of substitution. At first sight, you think, how are we going to find an unknown for, like, there's 3 unknowns and we have to find one of them is, out of 2 equations. It looked a bit daunting, but because of the way this is set up, 2q plus r, 2q plus 2r, you can use some substitution there to do it. Okay, so you should never give up. Just look logically at things, lay things out very clearly and neatly, and things should work out for you there. Okay, so we know u is 4 over 15, and let's go to part C now. And now for part C, it says find the value, and it says given also that the variance of y is 37, find the value of q and the value of r. So we know the variance of y is 37. We're going to find q and r from that. We already know the value of this letter, which was u, for 4 over 15. Now the variance of y would be, if you remember this little phrase, the mean of the squares minus the square of the mean. Now we know that the expected value of y, or the mean, is equal to 0. So it's going to be just the mean of the squares. Take away 0 squared will be take away 0. So the mean of the squares is found by taking the y values and squaring them. So this is going to give you 81 and 25 and 0 and 25 and 81, and multiplying those by the expected values. So I'll have 81 times q plus 25 times r plus 0 times 4 over 15 plus 25 times r again plus 81 times q again, and we know that that's going to equal 37. So I can say that's 162q plus 50r is equal to 37. So that's like one equation that I formed from this information. And the other thing we know is that the sum of the products of y and the product of the probabilities of y is always well, we know that's going to be 0. We found that already. That won't really help us because it will just that won't help us because they add up to 0 anyway. Minus 9 plus 9 minus 5 plus 5. What will help us also is that the sum of the probabilities, the sum of all these probabilities, has to be equal 1. Okay, so if I just add together a q plus r plus 4 over 15 plus r plus q, that has to give me 1. So if I simplify that, to make that a bit simpler, so that's written in a more easy, just combine the like terms, have 2q plus 2r is equal to 1 minus 4 over 15, which is 11 over 15. So 2q plus 2r equals 11 over 15, which we actually deduced from the last part of the question, part B. Okay, but now what we can do is we can now solve these 2 equations simultaneously. We've got 2 equations that I can solve simultaneously. So for example, I could make let's say we make the r's the same. So let me multiply equation 2 by 25. So I'm going to have 50q plus 50r equals 25 times 11 over 15. It's going to be a fraction, but it's not a problem. Can deal with fractions. That gives you 55 over 3 Okay, and if I write next to that the equation that I'm going to use it with, this has got 50r in it as well. And if I subtract those two equations, I will have then removed. If I subtract this way, I'll have 162 minus 50, 112. Okay, so it's 112q. This is eliminated. Then I've got 37 minus 55 over 3, which gives us 56 over 3. So therefore Q is equal to 56 over 3 times 112. So divide that by 112. Gives you 1/6. So Q is equal to 1 over 6. Okay, so we found what Q is. Now we got to find what R is. So I could use, let's use this equation here. We could say that 2R equals 11 over 15 minus 2 times Q, which is 1/6. So we take this, multiply it by 2, and we do 11 over 15 minus the answer. That gives us 2/5. So 2R is equal to 2 over 5. Therefore, R is equal to 1/5. So we now found the value of Q and the value of R. Q is 1/6 and R is 1/5. Okay, so there's the answer to part C, just using a pair of simultaneous equations from the variance, okay, and then from the fact that they add up to 1. Now, remember, the variance is going to be this, and I didn't write this, but as I mentioned in the beginning, that the square of the mean is going to be 0, right? Because the mean was 0. So the variance is actually, as we did, the mean of the squares, which is found by multiplying these two, the square by the probability, and adding them all together. Okay, so you multiply the square of y by its probability, and that will give you, and you add them together, that will give you the mean of the squares. If you subtract from that the square of the mean is 0, so that's why I didn't do anything else to it. That's the reason. Normally, if the mean was something else, we'd have to take away the square of that, and then that would equal 37. But that's 0, so that's fine. Okay, now the next part of the question. Question 5, it says the coordinates of a point P are 12y. The random variable d represents the length of OP. Find the probability of the distribution of d. Find the probability distribution of d. Okay, so the length of OP is d. So we can say that d is equal to the length of OP, and the coordinates of P are 12y. So if we just make a little sketch of a pair of axes, just to show what's going on here. You've got do it the other way around. Your y values are all, your x value is 12, okay, and your y values are between -9, -5, 5, and 9. So let's say this is 5, and let's say this is 9. Okay, so you have a point here. That's a possible point for P. That's another possible point for P. And then you have -5 and also -9. So we have another 2 possible points for P. Okay, so from O to P are all that's one possible value for D. Let me make that. That's one possible length of D. That's another possible value for D, the length of those lines. Another possible value for D, another possible value for D. Okay, so D is basically the length of this line. Okay, so these are the points P, the possible points P. Could also be here as well. Okay, when y is 0. So you got 5 possible points P. Okay, but the length of these lines will be the same as the length of those lines. So we can just worry about these 3 values of D, because the D will be the same length here and here. All right, so we can think just about these values of D here. So D can either be this length here, which is 12. So D can possibly be 12. Okay, that's when y is equal to 0. And when y is equal to plus or minus 5, then D is going to be the hypotenuse of this right angle triangle, and it's going to have the length 5, 12, and 13. Okay, this is a 5, 12, 13 triangle. That's 12, that's 5, that length will be 13. You can work it out. 144 plus 25, that's 169. The square root of 169 is 13. Okay, and then when y is either plus or minus 9, D is going to be this length over here. If this is 9 and this is 12, this is like a 3, 4, 5 triangle. This is like 3 times 3, 3 times 4, so this is going to be 3 times 5, this is going to be 15. You could work it out as well using Pythagoras. You can say here that this is 12 and this is 9, and you can say that's 144 plus 81, which gives you 225, so that's 15. So those are the values of D for the values of different values of y. So D is a random variable which can have 3 possible values, 12, 13, and 15. Okay, so we've got to find the probability of each of those. So let's now make our table. So we can say we got D. Let's call it small d. Whoops. So we have D, and we have the probability that D equals D. And we know that D values can be either 12 or 13 or 15. And now, what's the probability that D is going to be 12? Well, that's when y is 0, which is 4/15. That's going to be 4/15. And what's the probability that D is going to be 13? Okay, the probability that D is going to be 13 is going to be equal to, the probability that D is equal to 13 is going to be given by when y is plus or minus 5. So, oops, what did I do something wrong there? 1 second. R is 1/5. So these two are 1/5. I think I wrote something wrong there. That should be 1/5 and that should be 1/6. I just copied them out wrong. That should be 1/5 and that should be 1/6. Okay, you didn't notice that. Okay, yeah, so we can see that when y is plus or minus 5, D is 13. So you got this plus this, that's 2/5. And when D is 15, that's when y is plus or minus 9. So it's going to be 1/6 plus 1/6, which is 2/6, which is 1/3. Okay, so that's the probability distribution. If you want to make sure that you didn't make a mistake, you can add them together. They should give you 1. So 4/15 plus 2/5 plus 1/3. That gives you 1. So you can be rest assured that you've done it correctly. So this is the probability distribution for this question here of D, where D is the length of the length of the line from O to P, and P is the y coordinate of P is the value of the y in our first probability distribution. Okay, so there's the answer for part D. Doesn't ask for anything else. That's it. 6 kind of easy-ish marks actually. It's not too bad. All right, so there we have the answer, and that concludes this question, which is question number 5 from the October 2021 International A-Level Statistics 1 paper. Thank you for watching. Other questions about or from this paper can be found in the playlist that should appear in this area Other questions about discrete random variables you'll find in this playlist. You can subscribe to my channel by clicking on this link there. Thank you for watching, and see you soon.